everybody. Today we're going to talk at personal protective equipment and also control of hazard in the workplace. So basically, I think I have the last class we talked about the prevention of occupational diseases. So prevention of occupational disease injury consists, one part of it basically consists of PPE and control of hazard in the workplace. So today we're going to focus on that, and some of this, since you're a practitioner, you might have more ideas of what is the right thing to do. But anyhow, we will just be discussing this so that we can get a better idea of what to do if in the workplace. All right. So good morning. Today is PPE and control of hazard in the workplace. Today is PPE and control of hazard in the workplace. The KQD 7003 Occupational and Environmental Health in Engineering. A very good morning again. So first we look at control of exposure, which is what we discussed today. So the idea is we're looking at what is the source of the exposure, what's the pathway, and who's the person affected. So I would like, I just got to, so the source and the path of the person basically exposed. Of course, we can look at it from different perspectives. We can look at it from the perspective of engineering also, all right, of the source of the hazard in the workplace. The source can be basically physical, chemical, biological, psychosocial, and agronomic. So the sources of exposure in the workplace are all the 5 hazards that we are focusing on. So, and when we look at the source, where can we basically control the exposure? We can control exposure at the source. We can control exposure during the transmission at the pathway, or we can control exposure from the personal perspective. So the source, basically, of course, we know that when we talk about control of hazard at the source, we look at what the hazard in the workplace basically can be biological, chemical, physical, mechanical, or psychosocial. So mechanical, we basically can talk about agronomics involving also, and psychosocial also can consider as agronomic. So biological, we know that there are basically different kind of biological hazard like viruses, bacteria, and fungus. So the main thing about biological hazard we must understand is that we want to know whether it is airborne, all right, droplet, or just by fluid. So if it's airborne and droplet, the prevention is different from when it is fluid. Chemical is the same thing. Is it from environmental exposure or from handling of the chemical? Of course, physical hazard, mechanical hazard, and psychosocial hazard. All this has been also discussed in more detail during the previous classes. If you have any problem with that, please let me know. So, do you have any issue with hazard identification in the workplace? Do you understand the different type of hazard in the workplace? Anyone have any issue? Is there any question? Okay, so I carry on. All right. So basically, when we talk about control hazard, we focus on hierarchy of control. Hierarchy of controls start from elimination, substitution, engineering control, administrative control, and personal protective equipment. Although this is the 5 hierarchy in the context is that basically you start from the most effective, all right, to the least effective, and that elimination means that we try to eliminate or substitute the source of hazard from the workplace. So elimination, let me repeat myself, elimination is basically it's very, very difficult for you to do unless you eliminate the whole process or eliminate the factors itself. So you cannot eliminate the hazard. Usually, let's say you are basically removing asbestos. Can you eliminate asbestos or not? You can eliminate asbestos, but can you eliminate the hazard related to the use of asbestos or not? Basically, the question is, what is asbestos used for?
No.
What's the use of asbestos? What is the basically, let's say you use asbestos as a fire retardant, as a fiber for binding. All right. So when you talk about replacement of asbestos as a binding agent, can you eliminate the binding agent or not? If you're talking about basically cement sheet, anyone working for a cement for a company to do producing corrugated roof or cement sheet here? Anybody got any idea? So the question is, if you are producing cement sheet or corrugated roof and previously you have used asbestos, so what can you do? What's asbestos used for in that context? If anyone knows the answer, please let me know. Or are you still there?
Not sure, Prof. I'm not working on the. No.
Basically, asbestos is a binding agent. So asbestos are fiber, correct? So fiber is used basically to bind the what we call the cement together, so that you can form a very firm or sheet of corrugated rooftop or asbestos sheet. All right. So if you say that you want to eliminate asbestos, yes, you can eliminate asbestos from the system, but you cannot eliminate the hazard that is related to the use of asbestos. So the use of asbestos in this context is basically a binding agent. So you need to what we call substitute the asbestos with another binding agent. So do you understand that?
Yes, Prof.
So but that means you need to replace the asbestos with another another type of fiber, so that the cement can bind together and form a firm sheet of cement sheet or corrugated roof. All right. So that is what we call. It's very difficult to eliminate a hazard, but you can eliminate the hazard, but you cannot eliminate the use of the hazard, use related to the hazard. So elimination is not really a good way of control of hazard. So unless you basically remove the hazard itself. Let's say you want to remove petrol. Can you remove petrol or not? Can you remove hazard related to petrol or not? You can. You basically, if you even use electrical, you still have some hazard, which is substitution of electrical hazard. So that's the thing. So the usual way that we do it is basically we do substitution. Same like what we do when we remove lead from petrol. What are we doing? Why are we removing lead? What when we say that we have lead-free petrol, what does that mean? Lead-free petrol. What does lead-free petrol means? When you go to petrol station, you'll see that the sign says that lead-free petrol. What does lead-free petrol means? Why is lead needed in petrol? Why do we put lead in petrol in the first place? You don't remember the class I taught in toxicology, or the class that Mazuki taught in physical or biochemical hazard? Why do we put lead in petrol?
Reducing engine knock.
Yes, all right. So when you remove lead from petrol, so when you see the lead-free petrol sign in your petrol pump, what do you think have happened? Basically, they have removed the lead, but they need to replace with another substance that prevent the engine from knocking. All right. So the petrol still have other chemicals that inside the petrol that causes that remove the engine from knocking. So that means we are not eliminating the hazard itself. We are eliminating lead, correct, but not eliminating the use of lead associated with the use of lead. So we're just substituting it with another hazard. So that is the important thing you need to consider. But the other issue that you need to consider is that when you replace something, when you substitute something with, let's say, another substance, you need to make sure that the affinity or the quality of the substance that's used to substitute the substance would be the same. Let's say you say you don't want to use alcohol sanitizer in your workplace now, correct? Now everybody use 70% alcohol sanitizer because that is the recommended that you can use 70% alcohol sanitizer in the workplace. And then you say, okay, I don't use alcohol because I don't like alcohol. I want to use another substance. So if you want to replace it with or substitute it with another chemical, make sure that the chemical itself can act as what the alcohol itself is supposed to act, right? So that is also important for you to consider. So elimination and substitution. So elimination is removing the hazard or hazardous work practice from the workplace. This is the most effective control measure. Usually it's very difficult to eliminate a substance unless we could eliminate a process or procedure. That's what I try to discuss, try to emphasize to you just now. All right. Substitution means the toxic substance that pose danger to the workers or the community could not be removed then to a less toxic substance, then we substitute it with a less toxic substance. Like what we do is we substitute asbestos containing material with other type of fibers, which is less toxic compared to asbestos. We substitute lead with other chemicals, which is less toxic compared to lead. And we substitute mercury in the batteries with other metals that is considered less toxic compared to mercury. So what have we substituted? We have at one time we have basically used nickel, cadmium. And now we are using lithium, and we are basically improving or changing the metals because of also improving in technology. So we are removing mercury from batteries. We're also removing mercury from lamps already. Last time some of the lamps basically are mercury lamp. So we're replacing it with other kind of more of diode. All right. So LED lamp. So that's what we call substitution, because we cannot remove the use of the mercury battery. We cannot remove the battery, so we need to replace it with another material. So we cannot what we call eliminate the process itself. So those are the things that first thing you need to do in the top of the hierarchy of control. But if you cannot achieve that, then you need to do what we call engineering control. So engineering control is basically on the principle of either you minimize the exposure or minimize the release, or control release or isolation. So usually you try to minimize the release, or you want to control the release, or you want to isolate the process so that workers are not exposed to the process. So what do? You use local exhaust ventilation, general ventilation, isolation, barriers, especially like sound barriers. You can use guard, either mechanical or electronic guard. You can use silencer as the source of the noise. All right, so where is silencer being used? Basically, if you look at your motorbike, you have silencer, correct? So the silencer is basically used for two purposes. One is to reduce the noise. The other one is to increase the combustion capacity of your engine. So the silencer is there to reduce the noise. Right, so that is a silencer. That's the most basic example that I can give of a silencer. The exhaust is the silencer. So if engineering control cannot be administrated, or sometimes you need to combine both engineering and administrative control. So what is administrative control? Administrative control means that you have a standard operating procedure that ensure that there is regular maintenance of equipment, there is good monitoring of the process. Although you ask people to do something, or you have the thing there, you need to have an administrative control to ensure that there is a monitoring. You have a checklist before you actually use the equipment. This is very, I saw a very good practice that day. I was basically waiting for a bus after I disembarked from the MRT station. All right. So when I was waiting for the bus, there was a change in the driver. So the new driver actually have a checklist to go around the bus to check that everything is in order, so that before he actually go on and start the bus. So that is a very good practice. Basically, you have checklist in the morning before you actually start work to make sure that all the things, all the equipment, all your safety procedure, all your safety processes are already in place and are functioning before you start work, so that you don't endanger yourself and you don't endanger others. So this is called administrative control. Rotation of staff. Rotation of staff basically is to reduce the hazard that the staff is going to face because of the amount of hazard in the workplace. So you can actually rotate the staff. Of course, you must understand that when you're exposed to chemical in the workplace, even though if you want to rotate the staff, you cannot exceed the maximum exposure limit. All right. So the maximum exposure limit cannot be exceeded, although you want to say rotation of staff. Although the TWA is below that, but the maximum cannot be exceeded. Limitation of working hours is another way of doing the reducing the hazard, which is basically same like rotation of staff. Of course, the last and the most what we call last defense that you have is using of personal protective equipment. The last defense that you have is basically ensuring that the workers use their personal protective equipment. So what is personal protective equipment? Equipment or clothing that is worn to protect workers against or minimize workplace risk. So that's what we call personal protective equipment. And of course, it's a last option because it transfers the risk from the employer to the employee. So this is an example of risk transfer, when you can transfer the risk from the employer to the employee. All right, let's recap. So we have hierarchy of control, we have elimination, substitution, engineering control, administrative control, and personal protective equipment. So effectiveness, the most effective is of course elimination, and least effective is PPE. And also basically we can also discuss on what are the workers' participation. What means how much you need worker to participate in the process. The least you lead to workers' participation, the more effective the process is, because it's not prone for human error. That means you need to look at a system, design a system to reduce human participation in a decision making, as to reduce the human error or variability in human behavior. We know that the human behavior varies between person and person, and also varies within the person between days, so that is basically difficult to control. So we try to use processes that eliminate the decision that need to be made by human. So engineering control. So now what we're going to do is we're going to go in and discuss in more details what are engineering control, what are basically elimination, substitution we have discussed earlier. So we are going to discuss more engineering control, administrative control, and personal protective equipment. So we're just going to look at some examples, and from that examples, then you can basically learn something from it and use it in your practice. So what is engineering control? Engineering control is basically like you isolate the process or you enclose the procedure. All right, what you see here is basically a gas. This is called ethylene oxide. Ethylene oxide is a gas that is used for sterilization, or is it good to use for cold sterilization? Anyone understand what's the difference between cold sterilization and hot sterilization? Anyone? Anyone know what's sterilization?
It's a process to remove bacteria from particular items.
Killing the bacteria.
Yeah, okay. So basically sterilization is to sterilize is to basically disinfect the equipment, all right, or any other equipment or materials, so that it is the biological contaminant are removed. That's called sterilization. So we have what we call cold sterilization and hot sterilization. Hot sterilization is when we use autoclave. All right, so we know that bacteria or viruses or any biological substance, when you use autoclave, they would be destroyed. But the problem is autoclave is sometimes it is basically not good for some equipment, because some equipment are sensitive to heat, and when you autoclave it, the equipment, the lifespan of the equipment would decrease, and also the effectiveness of the equipment would decrease. So you basically can use what we call other kind of sterilization method, which is called cold sterilization. Usually what we use in cold sterilization is that we use chemical. So one of the chemical that we can use, or the gases that we can use, is ethylene oxide. Ethylene oxide is a good chemicals that basically is good for sterilizing equipment, including medical equipment. So in this process, basically we are using a closed loop process. What you can see here is basically what you can see here is the canister. So this canister is basically put inside this something like oven, all right, and then all the equipment is put inside. So the sterilization happens in this oven, and after the complete sterilization, the gas is basically released into the environment, and then before we open it. So we look at the danger of it: ethylene oxide, cancer hazard, reproductive hazard. Authorized personnel only. Respiratory and protective equipment may be required to be worn in this area. So basically, if you are using it within the closed environment and the machine is functioning properly, this personal protective equipment is not needed, because it is a closed loop or closed environment. And this is what is something we call engineering control, where basically we design it into the system, and this gas basically does not leak, and this one does not leak if the equipment is functioning properly. That's why we must also combine both engineering and administrative control in place to ensure that the servicing and the machine actually function properly.
Prof,
Yes.
you see about the hot and cold, right?
Right.
UV is under hot.
Cold sterilization.
Cold sterilization. Okay.
Only autoclave is hot sterilization.
Only autoclave. Okay. Thank you, Prof.
Yes, because autoclave basically increase the temperature up to 140 degrees, correct? So because it increased the temperature up to 140 degrees for, I think, for 20 minutes, so a lot of equipment are not able to withstand that. But it is important to know that although you say UVC is basically can be used for sterilization, but some equipment which is sensitive to UVC, we also try not to use that. All right. Basically, of course, we know that when you expose equipment like rubber to UVC, then basically the rubber would degrade because of the reaction between the chemicals in the rubber and the ultraviolet light. So you use basically sterilization method according to how long or how effective the sterilization method is, and also how easy the sterilization method would have on your equipment. Okay. All right. So closed loop process, ethylene oxide delivered in an enclosed system. Of confining or isolation word processes, basically this is using sound barriers. All right, so you can have both absorptive material and also reflective material, correct? So sound barrier is an important component. So you separate the noisy area from the quiet area by using either direct material to absorb the sound or to reflect the sound. Okay. So, but the problem, we know that when you have too many reflective surfaces in a small room, you get what we call, what do you get? What do you get when you have too many, when you have noise in a small room, noisy area in a small room? Any mechanical engineers? Any engineers here? That means the noise doesn't only come from the machine. The noise comes from the reflection from the other materials in the room, like your walls and your other equipment. So you have what you call reverberization. That means there is a two noise might join together and you must increase the noise level. So that is also important. So all these things are engineering control, and it needs to be designed properly by an engineer that is basically in the know of how sound actually travels and what materials actually are used, can be used to absorb the sound. The other engineering control is basically by use of mechanical assist, pump, transfer chemical, of course the bottom loading. All right, that's what some of, okay, bottom loading. All right, of tanker. Then guard is basically can be mechanical guard or electronic guard. Basically, guard is a way of basically stopping the machine when the or to prevent the hand from basically getting entangled in the machine. So the simple one is basically your fan and the grill in front of your fan is a very so this is both mechanical and electronic guard. Mechanical guard means that the area within the machine move is basically have a fencing, but also there is a electronic guard at the door. Where you open the door, the machine actually stops immediately. So there is both a mechanical and an electronic guard. So this is called guarding system. Other method of engineering control includes ventilation system. So this has become a very hot topic, very important topic that basically I hope all of you would have a good understanding and know what to advise your company with regards to ventilation system, because we know that currently COVID-19 is a airborne biological agent, and if you are not familiar, you don't understand how engineering control, how a ventilation system works, then it might spread within the compound itself. For those that want to understand more about ventilation system, we have a webinar 2 weeks ago, and the video of the webinar is available on our YouTube page. Have anyone seen that, or did anyone attend to that webinar? It was on the 28th of December 2020. Anyone attended that webinar?
No.
No, sir.
All right. So no problem. I will share the link in the Spectrum later. So if anyone want to get more information, can basically go and listen to the webinar. It's very interesting because the webinar, we have three prominent speakers from two from engineering, mechanical engineering, and one from architecture. All right, so we have three prominent speakers from University of Malaya that actually discussed in the webinar. So that basically discussed clearly about ventilation system, about office design, about natural ventilation. So it's good that you all should basically go through that part and understand it. Although it's focused on hospital, but basically you can use it anywhere else. So what is the use of ventilation system? Ventilation system, the first thing is the supply of adequate oxygen, because we need oxygen to basically function. All right. So if we have lack of oxygen, although before we basically succumb to the lack of oxygen, basically it reduce in the functionality of our work. So basically the supply of oxygen is important so that we can function properly. So the other one is to prevent or build up of airborne hazard. So there are basically many airborne hazards in the workplace, especially as I mentioned earlier. COVID-19 is SARS-CoV-2 is an airborne bacteria as a virus hazard that need to be removed. And we must not forget that ventilation system also is there to maintain a comfortable environment, to reduce the heat and maintain the humidity. So the idea is that you need. That's why for those who basically are in the non-industrial environment, your workplace should comply with the IAQ guideline or IAQ code of practice that Josh have actually proposed or is available in Josh's website. Right. So for those, IAQ is indoor air quality, component of indoor air quality. So there are two types of ventilation system. One is a general ventilation where we have to ventilate the whole room, and then the air within the room is replaced in a certain number of times, or certain in the whole air in that room is replaced in certain number of times within an hour. All right, that's what we call air exchange per hour. All right. And then the other one is local exhaust ventilation, where basically we need to ensure that the contaminant is removed from that area directly instead of contaminating the entire room. So that's why we use the local exhaust ventilation. So what general ventilation? Okay. Tell me what happened here.
The air is moving around. It's not a stagnant air.
So what type of ventilation is this? What is this? What diagram am I showing? Mechanical engineer, are you here?
No, Prof.
No mechanical engineer. Never mind. Anyone know what is this or not? Know what am I showing?
Is it a closed loop?
Airflow movement, sir?
Yes, it's airflow movement. I agree. But what system is this?
Is it a closed system?
Sorry?
System.
Sorry, can you please speak a bit louder, because sometimes your click cannot hear you. Just speak slowly and loud. All right, please.
Looks like an air
Dilution?
conditioner.
Air conditioner, yes, very good. It's an air conditioner. What type of air conditioner is this?
This one is in the plant actually, Doctor.
There's two types of air conditioner. There is a centralized and there is a localized or air conditioning system. What is this?
This one is like more to like standardized.
Okay, this is a centralized air conditioning system. All right, so it shows a centralized air conditioning system where basically it is the air comes from another area and it flows with it, and it comes to, and it's basically make it it is cold and it's dehumidified, and then it's basically circulated in the air. So this is what your external unit is. All right, this is an external unit outside the building where basically liquid flows within this unit. Can you see the liquid? The blue and the red line. So the red line is the return hot air, and then it's cooled. All right, so the liquid cool within that, and this is where the air exchange occur. So fresh air will comes in from the environment. All right, then there is what we call a actuator, or to control the amount of air, fresh air actually comes into the system. So fresh air comes from exteriors, it goes to the system, it is filtered. So there is a filter here. So this filter can be any type of filter, can be a HEPA filter, or HEPA grade filter, or can be a lower than HEPA grade filter. And then the air is cool. And then when you use this is basically the vent on top of your air conditioning system. The vent, the cold air will go down, and the air basically will circulate, the cold air will circulate within the room. This is called a centralized air conditioning system. All right. So what is the idea of this? Is basically this one, we have fresh air coming from outside. All right, and that is important. There's fresh air coming from outside when you have a centralized air conditioning system. we know that cold air is heavier than warm air. Is it correct? All right. So cold air is heavier than warm air. So that means that during the period when you are inside the room, inside a centralized air conditioning area, the cold air would remain at the bottom, heavier, and then when it becomes warmer, basically it will just rise to the top. So at the top here, basically what you have is a warmer air. So the warmer air will basically go through the return grill, and there is a damper actuator, and basically it can be released into the exhaust, or you can basically recirculate and mix with the fresh air from the external, and then it flows through again, and then the circulation basically happens within the room itself. So there's a circulation of air within the room. All right. So this is what happened. This is basically cold air coming in. All right. It circulates within the room. All right. When the air becomes warm, it goes back up, and then it's recool again, and it comes back in again. All right. So it recool again like here. It goes up, and you get recool and come back in again. Can you tell me what's the problem with this type of circulation in Can anyone tell me what is the problem? What is the issue with this type of circulation? Anyone?
Not sure, Prof.
Prof, I think this is it has a poor ventilation.
Sorry?
I think it has a poor ventilation system.
No. What is the problem with this? It's not poor ventilation system. There's no poor ventilation system. What's the problem with this ventilation? This is what you get in a normal air conditioning area. In your office, that's how the aircon actually works. All right, you have a inlet where cold air comes out, and you have a return grill where the hot air actually returns back into the circulation. So what is happening here? We don't have mechanical engineer in this group, but do we have? I think we have, but at least one. What's wrong with this system? What happens if there is a person here inside this room which is COVID positive, and then what happened to the bacteria or virus that is when the fellow actually cough and then is inside the room? What happened?
The virus will be carried to the entire building.
Basically, you look at the circulation. Is what we call the cold air recirculate within the room, correct? So the cold air actually recirculate within the room. This is the normal design of an office. Why is this normal design of an office? Because it is more efficient. It's more energy efficient. All right, design. So there is a flow within the room. So this is more energy efficient compared to another design that I will show you later. So only when the air coming in become warm, only it will return back. Yes.
Is it like a centralized aircon system?
This is a centralized aircon system.
Oh, okay.
I show you this what I show you here. This is a centralized aircon system. All right. Okay, this is a centralized aircon system. The air will comes in. All right. This is the same thing as what you have in your office, centralized aircon system. It will circulate within the room until the air become warm. Then it will go up, and then it will basically return to the return grill. This is all thermodynamics, based on thermodynamics law. All right. So the idea is that the air will circulate within that. So in a normal office, all right, the air exchange per hour, that means the whole room, the air is replaced with fresh air from outside. In a normal practice, in an office, is only 4 times an hour. All right, that means every hour you have 4 times fresh air coming into the room. That's called air exchange per hour. So it's 4 times per hour in a normal what we call office area. So the air actually stays in the room for at least 15 minutes. So if you are coughing and you're sneezing, and then the air actually stays within the room for 15 minutes. And we know that when you're exposed to a person with 15 minutes within the room, the chances of basically getting COVID is higher. That's why in an office, when you're in an office, you're supposed to continue to wear your face mask, although you are sitting not so near from. If you are in a closed office, it's basically or small office for you to wear face mask all the time, because the air is basically exchanged only once in 15 minutes or 4 times an hour. In a place like this, which is basically an ICU or in a hospital environment, the air exchange is up to 12 times or 20 times an hour. All right. So 20 times the air change per hour. Why do we don't do it in an office? Why do we don't do it in an office to increase the air exchange from 4 times to maybe 12 times or 8 times or 20 times an hour? Why don't we do it? Anyone?
Due to cost.
Yes. How is air cooled? Basically, when you look at this system, every time the hot air will need to be cooled, correct? So basically, there is a circulation here to cool the air until it become cold. So if you have exchanged more times, you need the fan need to be more efficient. The cooling capacity need to be more efficient. So the energy cost will increase. So we don't do it in an office environment. We can do it. All right. Not say we cannot do it. We can do it. And some of the AHU, air exchange unit, can actually handle it, but because of costing, we don't do it. All right. So that's why it's important for you to understand that when you are in an office, this is what happened. This is basically what we call more of turbulence flow within the room, where air actually flows is not in a laminar fashion. All right. So this is how air flows in a laminar fashion. All right. So air will flows in, cold air will flows in. All right. The return is actually at the bottom, and of course the return is also within the toilet itself. So the cold air who comes in, and the return goes there. So this is called a laminar flow. A laminar flow will reduce the turbulence within the room, and also will reduce the transmission. So if let's say I'm standing on top here and my patient is down here, so basically I would reduce the chances of me getting infected because of the laminar flow. And usually laminar flow, the air exchange is around 20 times per hour, and it needs to be cooled properly. So 20 times or more per hour. All right. So this is called laminar flow. And if in OT, this thing actually consists of HEPA filter. So all the air coming in are actually fresh air. So this is what I'm showing you here is an ICU within UMMC. ICU is an intensive care unit within UMMC, and this is what we call an isolation room, where we basically ensure that there is a negative pressure within the isolation room, so that the contaminated air within the room does not escape to the outside. All right. So currently you will heard of negative pressure room and positive pressure room. Negative pressure room is when the air does not escape outside. This is called a negative pressure room. Clear? All right. So let us continue. So this is basically air exchange from general ventilation.
Doctor,
Right.
what about a public transportation system like in commuters and I mean bus and so on? Are they having all this air exchange units?
Basically, if you talk about bus and things like that, all right, it is almost similar to this one. Okay, similar to this, where the fresh air comes in, and then the fresh air goes out. So your bus system will be like this. All right. So you have a cooling system in front, correct? And then the air will basically be circulated within this until it becomes warm. Then it will be excreted to the outside. That's why it is important for you to understand when you're traveling in a closed environment like a taxi or e-hailing, it is good that you open the window to let fresh air in. All right. So you open the window to let fresh air in, so that you can actually be more so that you can ensure that you don't get into contaminated air. I'll show you a video that I have produced, all right, so that you can have a more clearer idea. Okay, so this is the diagram for a car. In front of the car is the engine compartment. This is the compressor and the condenser. The compressor actually compresses the gas from a liquid to gas. So so you know that your liquid to gas, and then the blower actually blower and evaporator actually is within your room, within your cabin. All right. So the blower unit will suck air within the cabin. All right. So there's two units. There's one unit in your engine compartment. All right. There's one unit in your cabin. All right. So the unit in your engine compartment and the unit in your cabin is connected by tubes. Basically, they contain liquid. All right. So the hot liquid is basically cool, and then it is cool, and the cool liquid is basically circulated within the cabin, within the compartment of your car, and in the internal unit. So the air is actually cool and compressed within the internal unit. All right. And then it's basically circulated as what is circulated. So here's the picture of an aircon control panel. Can you see this? Can you see the C there? What does the C means?
Circulation.
Sorry?
Circulation.
Sorry?
Circulation.
What do you mean by circulation?
The flow of the air in the car.
Yeah, what do you mean?
It's recirculate the air.
Yes, it recirculates the air, all right? So there's no fresh air coming from outside, correct? So the air recirculate within the system. That means there's no fresh air coming from outside. Why is there no fresh air coming from outside? Why do you need this? Because you want to cool your engine, you cool your cabin more quickly. So you want the air to circulate within the cabin. You know that when you look at it this way, all right? When you look at this diagram, the air actually need to be cool, all right? And if the first time the hot air goes into your cabin, it is not cool, all right? So it needs to go through your cabin, your cabin compressor many times before the air becomes the temperature that you want. That's why to have cooler temperature inside your car, usually you recirculate, you turn this on so that the circulation within the car is basically the air is recirculated. All right. So what is the problem with this?
There's no fresh air coming in.
Yes, there's no fresh air coming in from the outside. So all the air is circulated within the cabin, and your cabin is considered a confined space, correct? The cabin of your car is considered confined space.
Yes, Prof.
Confined space in the context of what COVID-19 not confined space in the context of confined space defined by DOSH. All right. So it's a very cramped area. So if you don't recirculate the air within the area, basically the contaminant would flow within that area. All right. Understand?
Yes, sir.
Yes, Prof.
So this is another picture, all right? Some of the older car, they have these two, correct? This is from from a Pro Dual car. So you have recirculation and fresh air. So you can either turn to fresh air or recirculation. So this is manually you have to do it. In the newer car, basically it's automatic. Where the air becomes too cold, basically fresh air will come in. So recirculating or fresh air. This is recirculating air. This is fresh air. All right. So when you click recirculating air, what happened? So there will be no external fresh air coming in the cabin. So the blower sucks air from the cabin, cool it down, and then recirculate it within the cabin. So there's no fresh air coming in from the cabin when you are so when someone sneezes or cough inside the cabin, when he's not wearing a face mask, the virus or bacteria basically stays inside the cabin, and then he or she may get infected from the virus because it stays in the confined space. Okay, if you're traveling for a long distance, stays for more than an hour, the oxygen will come down and the carbon dioxide will go up. And this is because there's no fresh air coming from outside. That's why you will feel tired for a long journey because there is no fresh air coming from outside. So the idea is that you need to off the button after around 45 minutes of your car. So your blower unit is usually located behind the glove compartment. So there's a filter inside the blower unit that filter the external fresh air and also filter the internal air. All right, so it's just like what I showed you just now in the centralized air conditioning system. So in most cars, the air filter is not HEPA air filter or high efficiency particulate filter. So your normal filter is the efficiency will only go up to 98%. Your HEPA filter will go up to 99.97%. Which can filter bacteria and viruses. So 99.97% can actually filter bacteria and viruses. It can filter your COVID. Right. So if you turn on the fresh air button or you turn off the recirculating button, fresh air comes in. All right. So if you have fresh air coming in all the time, the chances of getting bacteria or viruses will be much less. So the advice to reduce the risk of COVID-19 infection or traveling in evening car is wear a face mask, allow in fresh air, change to HEPA filter, or wind down the building. Well, wind down the windows, allow fresh air into the room. All right. Okay, let's stop this and go back to our teaching. Okay. All right. So that's what happened in your car. All right. So what happened in your car is similar to what happened in the centralized air conditioning system. Okay. So general directional ventilation is usually useful for following conditions: small quantity of airborne hazard released at a uniform rate, sufficient distance between worker and source of hazard of low toxicity, and no need to be filtered before discharge in the environment, because it's clearly non-toxic to the environment under the Department of Environment criteria. So of course we know that component of general ventilation, you need a fan, duct, inlet, heating, cooling, and filtration. So the filtration is the one that we need to look at it. So most of the filtration that is in your office basically are not HEPA filter. You can actually change to HEPA filter to ensure that the air coming back, recirculating air, is basically fresher or better than circulating air. But also we will understand that although they say that you put a filter there, the recirculating air is fresh, but the air within the room would be recirculating because of the air. We'll call that the air exchange per hour. You in a normal office you need 4 times, so that's the issue. Right, this is what I asked you just now. All right, so what are these button means? So this button is the recirculating air button. So if you on this recirculating air button, then the air will circulate within the room. All right. So what are the advantages and disadvantages of general directional ventilation? It's basically easy to install, no need qualified person to design, easy to operate, low maintenance, and no need regular monitoring. Advantage is difficult to control exposure, large volume of air move, cannot be used for highly toxic substances. The toxic substance will be spread all over the production area and can be costly because of the electricity used. So just now we look at centralized air conditioning system. Can anyone tell me what happened in a split air conditioning unit? Anyone all of you use split air conditioning unit for your house, correct? Most of the time. What happened in the split aircon unit? Is there fresh air now?
It's not fresh air, sir.
Okay, so in a split aircon unit, there's no fresh air. The air just circulates within the room and is cooled within the room. So it's just like what you do when you press the circulation button in your car. There's no fresh air coming in. So the air actually goes within the room itself only. All right. So what happened is, if you stay in the room in a aircon with split air conditioning unit, there's no fresh air coming in. It's just like what happened in the car when there's no fresh air. You will basically, the bacteria or viruses or contaminant will basically circulate within the room, and you would have increased carbon dioxide and decreased oxygen when you're in a room for a long period of time. But of course, in the room, we are not worried because in the room is quite big, so the carbon dioxide and the oxygen level won't be a factor. The only factor is the contaminant which stays in the room when you're using split air conditioning unit. That's why it's important to understand that when you are in a laboratory setting, split air conditioning unit is no, all right, unless your chemicals, you only use it within a biological cabinet or a normal or under local exhaust ventilation. All right, so you cannot use the split air conditioning. So what is the use of split air conditioning? Split air conditioning unit is actually to just cool the air to make the environment more comfortable. So then we have a local exhaust ventilation. Principle of local exhaust ventilation is the source. Enclose the source as much as possible. Capture contaminant close to the source. Air withdrawn at high speed. Removal up to 100% of the LEV is properly done. Of course, the LE, we have the hood, the air duct, the fan, the air cleaner, and the stack. So all this must be designed properly by a mechanical engineer, and it must be maintained, and it must be, there should be annual, what we call assessment, because under the Department of Occupation, under OSHA regulation, you need annual assessment when you're using a local exhaust ventilation, and basically you need a hygiene tech 1 or hygiene tech 2 to actually do it. So the hood design depends on how much carrying capacity or how much suction you want from what you're doing. So it depends on what you're doing, and depends on what are the what we call that, the chemical or the hazardous substances you are using. All right. So of course you have what we call enclosing hood that actually have no external air that's to contaminated. This is basically used more for highly hazardous substance, biological substances, highly hazardous chemical substances. Then you have what we call depends on the airflow. All right. So what can you see here? Can anyone tell me?
Process of painting a car.
All right. Okay. And what is the importance of this design? Basically, it's a laminar flow. All right. If you look at it, it's a laminar flow where the air actually comes in from one side and go out from another side, and then it sucks in, so that we know that there will be less chances of the contaminant to be spread all over the area. All right, can you see this? Same like what we discussed just now, the laminar flow. All right. So it's usually this is called laminar flow. Of course, this is capturing hood near to the source. So this hood are basically a mobile hood when you can move it around to the source of your work. Of course, you can have suction within the machine itself already to reduce the hazard, or within the equipment itself. And this is how some of the unidirectional flow that we can see. All right. So there's the suction, and then the fresh air is blown from behind. So the fresh air will be able to cool the worker down, and the contaminated air will be sucked in front, so that the worker would not be affected by the contaminated air. So what is the issue when you do welding? You get fume, and then that is where you need to suck the fume. So you must design the LEV based on the hazard itself, whether it can actually suck the fume or whether it can filter the fume. Okay. Then the ducting also important. You want to see how you control the ducting system and where the ducting goes. And of course, the motor and fan is what is the efficiency of your suction. All right, and we want to ensure the suction is efficient, and then of course you need to know whether you need an air cleaner or not before you actually allow the air to go out to the compound. The advantages require less airflow, contaminant not spread all over the workplace, can be very effective if designed properly, can recover reusable material. So the main thing is that it can recover reusable material. That means material that's spread can be recovered and it can be used later. Disadvantage: difficult to design, must be done by a trained engineer or a mechanical engineer. All right, only effective in closed source, expensive to maintain. Constant regular inspection and for full effectiveness and need to be conducted by competent person. So it's a hygiene tech. All right. This one shows you a video of laminar flow. All right. Clean air comes from the outlet. Goes through the return air system. This is called a laminar flow, which means that the air, the dirty air does not circulate within the room, and it goes through the ceiling and then it's returned to the outside, where it mixes with fresh air from the outside. In the external compartment, they have laminar airflow system. They have positive pressure with AHU, 20% positive pressure with AHU. This is inside the OT system, OT environment, where we need positive pressure instead of negative pressure. Positive pressure means that the air does not fresh air from outside does not come in. So the air is sucked into the blower, and fresh air is basically come in 20% of fresh air every time. All right. So the air is circulated within the room. You have a HEPA filter. So HEPA filter is on the top, so clean air comes out every time. So there's clean air comes out every time, and so that the environment, the OT environment, the operating theater environment is safe. Any question on that system? Anyone? No question. All right, next. This is looking at biosafety cabinet visualization. All right, just follow the video. There's no voice, huh? Don't worry. Okay. Any question? What do you see? What's the issue? What's the issue you see? Anyone use biosafety cabinet, or anyone use fume hood in the fume cabinet in your workplace? None? No one using it? All right. So then we move on to administrative control. Administrative control is basically basically what we consider is procedure that minimize exposure while operating production and control equipment. Controlling employees' exposure by scheduling production and workers' tasks or both in ways that to minimize exposure level, conducting hazardous procedure during the time where there are less workers, rotation job or role. So there are activities that you can actually conduct outside the office hour, outside hours that is basically there are workers involved. So one of them, let's say your NDT. What's NDT? Anyone knows what NDT?
Non-productive time.
No, NDT, not P. ND.
Non-destructive test.
Yes, when you're doing non-destructive testing, how do you do non-destructive testing? What do you use usually?
We use something like infrared kind of thing.
Okay, so basically you use an energy source, all right? Physical energy source. One of it is infrared. You can use ultrasound. You can use X-ray. You can use chemical to actually do non-destructive testing. That means you don't have to open up the machine, and you don't have to destroy the machine, or you don't have to destroy the equipment, or you don't have to destroy the let's say the bar. So called non-destructive testing. So to do that, sometimes you use X-ray. So to do X-ray, basically you need to ensure that there are less people there when you're doing X-ray. So if you see all the columns, all the columns in the middle of the road that you see for MRT line, for LRT line, or for your car, all right, all those columns basically they do non-destructive testing to ensure that there's no fracture within those columns before they actually allow the other process to continue. So when there's fracture, they need to destroy the whole column, and then they need to build the column again. So fracture is the same, like, so they use X-ray to see fracture. So same thing like what we for machine also we do NDT, we use X-ray also. And of course machine when there is a fracture in the machine also you use X-ray to see whether there's fracture in the machine or not. So for those kind of activities usually conducted when there's less people. So it's called non-destructive testing. All right, for those people that don't have no exposure to it. Then we can have good standard operating procedure, SOP. Of course, we know now there's a lot of SOP around, especially on COVID. But problem about SOP is people don't follow SOP. So SOP includes stringent inspection and maintenance, good housekeeping procedure, close supervision, how to supervise. So mandating eating, drinking, smoking, chewing tobacco and gum, and applying cosmetic in regulated areas are prohibited, and encouraging good hygiene. So all those things need to be considered and need to be enforced so that people don't actually do it. Selecting PPE, before select PPE, you must understand the hazard that you're trying to use to protect the PPE for. All right, so that's important. So let's carry on. All this information are basically for you to understand what reference is it. The other thing that we need to consider is where to put our eye wash. All right, so eye wash or shower station cannot be another hazard. All right, and it needs to follow certain specification. One of the specification that it needs to be at least located within 55 feet, where a clear unobstructed path which can be reached within 10 seconds. So people who is basically having eye wash or shower station, you need to consider this. You need to ensure that this is practiced, because you want to make sure that people are able to wash all their chemicals if they have chemical hazard. So another thing about eye wash and shower station that I have encountered is sometimes they put it near electrical circuit. So that also is a no-no. All right. So you make sure that there's no electrical circuit or things like that near eye wash or eye shower. Eye wash is not so problematic, but shower station is much more problematic. Contact lenses. The idea is whether you can wear contact lenses in a working environment or not. Yes, you can wear contact lenses in a working environment, in a hot environment, in any environment. Because if the environment is so hot that it can burn your cornea, burn the contact lenses, you have burned your cornea already. So don't worry. The only thing that contact lens cannot be used is as a protective equipment. A contact lens is not a protective equipment. You need another glasses on top of the contact lenses. Okay, so don't worry, you can use a contact lens at any environment, unless the environment is too dry, then it become a problem, because when it's too dry, the contact lens stick to your eye, so that is the problem. So if there's enough humidity in the environment, then you should be able to use a contact lens. So what's hearing protective devices? So we have basically is to use to correct PPE. PPE have NRR, noise reduction ratio, so you need to understand the noise reduction ratio. So earplug and earmuff in the area noise more than 85 dB. So this is under your new what we call that legislation. Anything more than 85 dB, you need to wear earmuff or earplug. Double ear protection area of more than 97 dB. So you can see that all the earplug and earmuff there is a NRR. NRR is noise reduction ratio. All right. So some American have a different name, a different abbreviation, but the standard one is NRR, noise reduction ratio. So you need to look at the noise reduction ratio, but to calculate the effective protection is different. Noise reduction ratio is basically to look at if you look at this table. Okay, what can you tell me from this table? Look at it and see what can you tell me.
Laboratory more exposed to the more exposed.
Anyone else?
It means that the effectiveness of the NRR at real situation is not really good.
Yes, basically the real situation is different from laboratory situation. All right. So you must understand the NRR stated on your earmuff is basically laboratory NRR. It's not a real-time NRR. So real-time NRR, the noise reduction ratio is basically very much lower than your real-time NRR. All right. So that is need to consider. That is why basically you need to calculate how to reduce the NRR. So NRR is a single number description of the noise reduction capability of a hearing protection. So what you need to do for effective protection, you basically need to measure sound level minus NRR minus 7. All right, so NRR must minus 7 first. Then if you're using an earmuff, you must subtract another 25% from NRR before you actually minus the 7. You are using formable earplug minus 50%, and you're using other earplug minus 70% of NRR. Because all those are perfect fitting time. So if you say you fit your earmuff, it's easy, correct? You just put it like that. But you want to fit your earplug, you got to, some people, everybody's ear canal is different. So it becomes very difficult for us to standardize the earplug or design an earplug that is standard for your ear. So you need to minus that. So at the end, the effective NRR is basically much less than the NRR written on your chart, and you need to understand how to calculate it and how to get the effective NRR. So given that the workplace noise level is 98%, for formable earplug NRR is 29 dB. So what is effective protection, and at the end what's the effective noise level? So look at double protection. Earmuff, the recommended for area where there's high noise level. Double protection means that you put a earplug. On top of that, you put a earmuff. So you put a earplug and a earmuff. It's called a double protection. Right? The protection provides the double protection provides extra 5 dB than the two protectors. All right. So you just put one protector and you calculate for, let's say, your earmuff, and then you plus the 5 dB that will give you the effectiveness of using double protection. Step 1, calculate the field adjusted protection for higher rated protector, as I mentioned, your earmuff, your earmuff. Okay. Secondly, you add another 5 dB because you are using double protection. So don't have to calculate for the second protection. Let's look at the calculation. Earmuff NRR 23 derated, so it's 17.5. For mobile earplug NRR 29, so derated is 14.5. Effective double protection NRR earmuff is 5 minus 7, so it's basically 14.5 plus. Sorry, this is you're supposed to use. This is for. All right, so 14.5. No, you're supposed to use the year muff, basically 17.25. All right. So basically 17.25, you need to use the year muff to calculate, not the year plug. So this is something wrong here. Use the year muff. Right, it's 17.25 plus 5 minus 7. All right. So you get your effective protection, and then at the end you get the what we call the effective noise level. Are you clear? Are you clear on this calculation? Anyone? Are you clear on this calculation or not?
No, Prof.
What? Okay, you have a year muff, correct? Of 23. Sorry? Your year muff shows an NRR of 23. All right. Is it all right? Are you clear on that?
Yes.
Yes, Prof.
So when we say that you got to derate the NRR by 25% because it's a year muff, is it correct?
Yes.
So you minus 25%. So you're left back, your effective NRR is 17.25%, correct?
Yes.
Okay. Your formable year plug NRR is 29, correct?
Yes, Prof.
So you got to minus 50%, correct?
Yes.
So your muff become 14.4%. All right. So now basically what you need to do is you need to look 17.25. All right. Minus 7 is equals to 10.25. Correct. Okay.
Okay.
Is it 10.25? 17.25 minus 7, is it 10.25?
Yes.
Let's say your noise exposure is 98, correct? Is it correct?
Yeah.
So you minus 10.25, what you get? $87.75. Is it correct?
Yes, Prof.
So is that enough or not?
No, Prof.
It's not enough, correct?
Yes. Should
Very
be
clear.
under 85.
If you're exposed if your noise level, environmental noise level is 98, it's not enough for you for your protection. Is it correct?
Yes, Prof.
So what you have to do? You have to put another protection there, which is your ear plug, correct? So how you calculate that? It's 87.75 minus another 5 is equals to 82. Is it 82? Yeah lah. 82.75. Is it correct? Correct or not?
Yes, Prof.
So that give you enough protection or not?
Yes.
Okay, so that give you enough protection. That's why you need to know how to calculate it. Correct?
Okay, Prof.
So, anyone don't understand? Are you clear or not? Or want me to explain again?
Clear, Prof.
So you're clear. So basically, if you have if you're using a year muff, correct? It's written in the document that NRR, noise reduction ratio, is 23. And according to OSHA, you need to minus 25% first. Correct? So you do that. Same for your ear plug. Okay, if you use a ear plug alone, what is the effective protection? Can someone calculate for me? Only a ear plug. How much reduction can you get from 98? Anyone?
$90.5.
Yes. Is it okay? You understand?
Yes, Prof.
So 19.5, you're not going. Sorry. Hello. So 19.5 means that it's not adequate, correct?
Yes.
Okay. And you use a earmuff alone is not adequate. You use a earplug alone is not adequate. So you need to use double protection. That's what it means here. All right. Clear? Clear or not?
Okay, Prof.
Okay, then we'll carry on. All right, this is just to show you studies to re-emphasize to you that you must wear your hearing protection 100% of the time, not 50%, not 25%. Can you see this? All right. If you use your ear protection for half the time, you would be not protected. So this is another way of looking at personal attenuation rating. All right. So this is more of using another method. PR can be estimated for attenuation measure for one or more than one frequency. So this is field attenuation estimation system. So sometimes basically same like your fit testing. Earplug also you can do fit testing. All right. And fit testing is basically if you do fit testing, then you'll be more clear on exactly how much protection you can get from earplug or earmuff. So what we call that is we use FAES, field attenuation estimation system. All right. So basically to see whether your earplug or earmuff is properly fit or not. So it's called fit testing, same like for your. All right. So when you do fit testing, usually when you do fit testing is basically when you are having a new equipment, you want to make sure that everybody it fits the individual who's wearing it. So you need to do fit testing. All right, this is the equipment that can use for fit testing. Basically, sound microphone within the earplug or earmuff to check for your fit testing. So these are the same equipment, same earplug or earmuff that they use, and then they just put in a microphone so that you can pick up the sound, or put in not a microphone. Basically, this is more like a tube that actually collect the sound from the internal to interpret it as a fit, whether how fit is your equipment. So this fit testing, you have the employee insert their own protection, connect the microphone and begin speaker, test sound, and use a PR customized hearing protector selection. All right. So this is one way of doing fit testing. We have hand PPE. We know hand PPE is basically a different type of glove. We have butyl rubber. We have neoprene. We have nitrile, and we have nitrile and neoprene. Have you seen the video? The lessons that I shared that day about glove, about mercury, methyl mercury. Did you see that or not? Have you been to that lesson? Anyone? Never mind, if you have not go through that, just go through that later. It's in one of the links that I provided earlier. All right. So we know that different gloves offer different protection, and you need to use the correct glove for the correct protection. All right. Because of that, you need to understand what kind of rubber, what kind of material is it. So which is very good. F is fair and P is poor. All right. So we know that when you look at, okay, let's say you use chloroform in your workplace. What can you use? Chloroform. All right. Can you use latex or not?
Neoprene.
Cannot use latex, correct? Nitrile, maybe. The best is neoprene. Is neoprene good enough or not? Not really, correct?
Yes.
So you need to understand what kind of chemical that is in your workplace to use the right kind of glove, and also the right thickness glove. All right, understand or not? Remember the day when you use mercury, methyl mercury, not methyl mercury. I don't know which mercury you're talking about that day. So you see that different chemical needs different glove because of their chemical properties. Why can't you use chloroform? Why can't you use natural rubber or latex rubber when you're handling chloroform? Because chloroform is one of the chemical they use to produce latex rubber. So it's one of the chemical they use to melt, to dissolve the rubber and things, and do make the rubber glove. Okay, clear? Same for boots.
Yes, Prof.
So respiratory protection. So when you talk about respiratory protection, we need to understand. I think all of you should be very expert by this by now already because of the COVID-19. So you need to understand what you're protecting them against. Is it particulate or not? Particulate is what? Particulate is basically small particles. It's called particulate. Is it vapor or not? Vapor is what? Vapor is basically what is vapor? All right. Basically, it's chemicals that is in liquid during an NTP and basically vaporized. All right. It's called vapor. Mist is basically water vapor and gases, and also to reduce oxygen deficiency. So operating principle, you purify the air, supply the air. All right, so air purification, particulates, gas vapor, canister and cartridge. Powered, it can be non-powered. These are particulate filter. Particulate filter with a wild half-phase filter, full-phase filter, foldable medical mask, and full-phase filter. All right, so these are some of the filters available. Respiratory PPE can be non-oil resistant. N is non-oil resistant. So when you say N95 means what? N95 means non-oil resistance. R means resistant to oil. That means you can use it in the oily area. All right. And P is basically oil proof. It's basically is more. So when you think that okay, I use a better one, but the better one that means that your breathing become more difficult. All right. So you need to use the correct one. You're not just say okay because R is better than N, I use an R instead of an N. No, if your environment does not need you to use R, you don't use R, use N, because it's R, although it's N95 or R100 or R95, is basically the breathing is more difficult. Okay, so you must understand that. And you must understand your environment. So respiratory PPE, you get powered PPE. So when you use a powered PPE, basically you use a powered PPE when you are involved in activities that require you to use a lot of your cardiovascular or aerobic activity. So it's something like aerobic activity, you need to use a powered PPE instead of normal PPE. So when you say that during exercise we cannot wear a PPE because, yes, we cannot wear PPE because we are breathing against resistance and it will be harder for us to breathe and you might get hypoxia because of the increased oxygen needs that because we are involved in exercise. That's why we cannot wear a face mask. We cannot wear any kind of mask when we are doing exercise. Is that correct or not? Because that is what we are recommending, that if you are in a gym or you're doing exercise, please don't wear a face mask. Because when you wear a face mask, you are basically breathing against resistance and your oxygen level become lower, and then you can basically, because of exercise, your increased oxygen needs, and then you can basically faint because of the lack of oxygen. All right? Clear?
Clear.
Anyone? So these are PPE for face masks. All right. So there are different kind of PPE. All right. There are different what we call different needs and different standards. So that, let's say if you look at US standard, there's ASTM standard for surgical mask, European standard EN 14683 for surgical mask. So you look at it, there's level 1, level 2, level 3, type 1, type 2, type 3. So for normal use outside clinical setting, level 1 and type 1 is adequate. All right. But for clinical setting, we need to be at least level 2 and level 3. Not because of the filtration, all right, but because of more of the, also there is protection against liquid, All right, so ASTM SAM level 2 and type 2, basically there is a protection against liquid. All right, so level 1 is not. So for you also, basically we try to look at level 2, 98% of the filtration. So we have N95 also. What's the difference between N95 and KN95? Basically, the idea is that when N95 and KN95 and FFP1, FFP2, FFP3 is the different standard, but different from, because it comes from different country, and it also might, but the protection is the same. So it is not, it's not because it come from different country, the protection is different. It's the same based on the standard that they use. The only thing that you need to consider is whether the certificate is genuine or not, whether the mask is genuine or not. That's one thing you need to consider. Second thing you need to consider is the fit testing. So fit testing is important when you're talking about respirator. Okay, this is ATSM level 1, 2, and 3. If you can see that what's the difference between ATSM level 2 and 3 is basically your high fluid resistance. All right. So fluid resistance means that when there is a when fluid drop onto your face mask, basically you just flow down. It would not stick there, and you will not go into your you will not block your breathing, and you will not go into your breathing. So for surgical area, we recommend at least ATSM level 2 because of the moderate fluid resistance that we want. Also for the bacteria filtration efficiency is 98%, and the particulate filtration efficiency is 0.1 micron. So that's what we want to look. All right, clear?
Yes, Prof.
Okay. So these are some of the different kind of N95 standard around the world. In US, we have N95, it's called NIOSH. In Europe you use FFP2. In China, you use KN95. In New Zealand and Australia, you use P2. In Korea, you use class 1, KMOEL, and in Japan, you use different standard. So the idea is that different standard, the standard is tested by the company that tests the standard. So all the standards here are totally the same. The level is the same, but it's just come from different countries. So that also you need to understand. Same here, all right? So these are the filter. So what kind of filter can you see here? This is half face mask with what type of filter? These are called particulate filter, all right? What is the difference between particulate filter? Particulate filter does not filter against chemical because there's no chemical inside those filter. There's only fiber or filtration, fiber filtration. So all these are particulate filter. It can go up to P100. All right, P100, it means that there is a filtration of almost 100%, all right, or 99%. And this is a respiratory filter. You can see that there is a half face, and then there is a cartridge. It's a cartridge filter. These are particulate filter. So you can use both a cartridge filter together and particulate filter together. Cartridge filter is basically for chemicals, and depends on the chemical you use different kind of filter. All right. So all this cartridge filter contains what we call a absorbent substance inside the filter itself. So the absorbent substance there's a lifespan to absorbent substance, and it's important for you to ensure that when you use this filter, when you open it, you can only use it for 1 month. All right. Even if you don't use it, it can only last for 1 month. Then after that, you can throw away. And once you use it, there's a lifespan to it. You must make sure that it does not overshoot the lifespan. So different. If you are using different chemical, you need to ensure that you use the correct cartridge filter, because in the cartridge filter there are chemicals actually neutralize the chemicals that you're exposed to. All right, the substance that neutralizes the chemical you're exposed to.
And doctor, what is the lifespan of the normal disposable face mask that we are using right now? I mean,
basically, the normal disposable face mask is the lifespan. It depends on. Let's say you are using. Let's say you're talking about you using it for biological, correct? Then the lifespan is basically when you cannot breathe. That's all. So usually we say that for one day is okay because if you don't want to contaminate your mask, correct? Because if you just wear if you are wearing it continuously, you can wear it until it's difficult for you to breathe, then you change. If you are saying you want to keep it for next day, it's not recommended. All right.
All right. Thank you, doctor.
Unless you're using a reusable one, then you have to wash it. Okay. So for this type of mask that you're wearing now, for this type of mask, this one, okay, you can wear it for the whole day if you still can breathe. But let's say by afternoon it's difficult for you to breathe because you have a lot of liquid, you talk a lot, then all the liquid accumulate within the face mask itself, then it becomes difficult to breathe. Just change, please. All right. But if you don't talk a lot, you just do your work without talking, and then there's less liquid there, then your breathing won't be affected. Then actually you can continue, because you understand that when you wear this type of face mask, when you talk, there will be moisture, correct? So the moisture actually is absorbed inside. There is absorbent material in the inner surface of the face mask to absorb all your moisture. And when you absorb all the moisture, then the whole thing becomes very difficult for you to breathe. Clear?
Understood, doctor. Thank you.
So there's no lifespan to it, except for one day. Okay. Supply air can be air hose or airline. All right. Basically, air hose and airline is the same thing. Or SCBA, or self-contained breathing apparatus, positive, negative pressure in face and demand continuous flow. Used where there is lack of oxygen or during an emergency. So when it's an emergency situation, when you want to go into a room when you don't know what's the hazard itself, you use an SCBA. All right. But in an area where your hazard is very high, you can use an air hose or airline. So there's an air hose or airline where the oxygen they don't supply oxygen. You must understand they supply compressed air. And they supply air. They don't supply oxygen. You must understand that. It's not oxygen in the tank. It's air in the tank. It's compressed air in the tank. All right. This is not oxygen in the tank. It's compressed air. Because if you supply oxygen, you cannot breathe 100% oxygen. You get oxygen toxicity. So what is inside the tank? What's inside the tank is compressed air. Okay. Understand? Why is the regulator at the bottom? And when you go to scuba or self-containing underwater breathing apparatus, the respirator is on the top. Basically, this one is to make sure that the accident doesn't occur and people doesn't knock on the respirator. So the respirator is usually at the bottom. All right, for your SCBA, self-contained breathing apparatus. All right. For the underwater, you use SCUBA, self-contained underwater breathing apparatus. Use of respirator, select the right respirator for the right type of hazard. Fit testing to ensure proper fit. Fit testing is very important if you are using a respirator. That means an N95 or KN95 or a half face or full face. Of course, you don't do fit testing for your face mask or surgical face mask. Then you need to do medical checkup before you actually wear a N95 or a respirator, because some people have cardiac condition, and when you put a face mask in, they have difficult to breathe, and then they basically can succumb to cardiac failure. You need to train them on how to use it. You need to teach them how to do fit checking. You need to have a storage or discard area. So this is a selection of PPE. So it depends on the type of material. You need to select the right PPE. What is NORM? NORM.
Natural occurring radioactive material.
Okay, correct. Natural occurring radioactive material. So basically, these are materials that are present in the nature, and it is more high concentration if you are underground. All right. So it's called NORM. Or in a cave, also there's NORM. So it depends, because there's naturally occurring radioactive material. What's the norm? What's the norm? TENORM. You're going to Google, correct? So don't Google lah. What's the norm? The norm is technically enhanced naturally occurring radioactive material. It's called the norm. Basically, you concentrate it or the naturally occurring radioactive materials. That's what we find in the Linax plant in Gebeng, Pahang. Right. So different kind of hazard. You need different kind of respirator. That's important. So you need to understand all this. Let's say you're exposed to ethylene oxide. All right. So up to 5 ppm, you need a protection factor of 50, and you need an air purifying full face respirator gas mask with a chin style front and back mounted canister, provided protection against the compound of concern. All right, but it's assigned protection factors. But in a emergency situation, then you need to, when there's assigned protection factor is 10,000, then you need to use a SCBA. All right, so SCBA is a self-contained breathing apparatus. Escape, you can just use the air purifying face mask for escape, but escape means you straight away you go out, you don't come back in and help people. But it's better also if you can find use an SCBA if your escape is a longer route. So you need to do fit testing. So there's two kinds of fit testing. There is a qualitative fit testing. What we see here is a qualitative fit testing where basically the person is asked to wear the face mask or respirator, and then you put a hood on top of the person, and then you spray some chemicals into the person to see whether the person actually tastes the chemical or not. All right, this is called qualitative fit testing. So the qualitative fit testing is based on the fit tester, the person to identify the chemical. The other one is quantitative fit testing, where you basically measure the air after you fit, same like what happened in your noise. You put in a measuring probe into the mask to see whether any chemical is collected or not. So it's called quantitative fit testing. Fit checking is every time when you basically, before you go out, you need to fit check by basically blowing out positive pressure. You're blowing into it, and basically, and then you inspiration is sucking it to see whether there's negative pressure or not, before you actually go, and every time you wear a face mask to see whether it's properly fit or not. Okay. Final one is body protection. Same here, body protection. It depends on the chemical you use, depends on whether what you are protecting against for, whether it's heat, splash, cut, hazard chemical, or radiation. So it can be any of this: overall, coverall, paper, light fiber, disposable chute made of material, protection against dust and splashes, treated wool and cotton. Protection clothing made for treated wool, cotton, adapts well changing work environment temperature. So you must understand that, let's say the paper, light fiber, that's what we use in our currently in our laboratory. Sorry, in our healthcare setting, we use polypropylene polypropylene material, and not polyethylene. Polypropylene material is softer and basically it's breathable. All right. But it's still liquid resistant, so you use polypropylene material. So polypropylene material is written as PP. So you can use any other material, depends on.
Prof, the face mask, you see about the face mask, right? About the 80 SM.
Right.
Usually usually that in the market, usually how can we know it's the 80 SM or?
It's written there. You can see the box.
Oh, written in the box. Okay.
All right. So there are standard. Basically, type 2 is type 2. Usually it's type 2 in the market.
Type 2. Okay.
Right. Type 2 is good enough.
Type 2 is good enough. Okay. Thank you, Prof.
But if you use type 1 also is okay. But of course, for protection, use type 2 lah. But this is only for clinical area. But if you think that you want to do it for your what you call that, for your company, then it's better lah. All right. As I mentioned earlier, there's no lifespan for that, for those surgical face masks. Recommended to use it only once a day. After that, you throw it away. But during the day, if you feel that it's uncomfortable, you cannot breathe, you can actually change it. The other way is that when you go for lunch, where do you keep your face mask? You can give their envelope and then ask them to keep in the envelope. All right. Then after that, they can remove it and they can take it out again. So you fold your face mask inward, so the inner surface is inside, so that it's keep from the outer surface, which is dirty. Any question?
And doctor, what about like 3-ply mask and 3-ply filters and 2-ply filters? Is it like true that 3-ply filters is more effective than 2-plies?
Basically, the 3-ply filter is what the current phase, the ATSM 1, 2, and 3 are basically, those are based on 3-ply mask. It's not 3-ply filter, it's 3-ply mask. All right. So there's 3-ply means that there's three layers, correct? Is it correct?
Yes, doctor.
So the first layer, the outer layer, is for water resistant. It resists against water. There's the outer layer, the blue color layer. All right. Then you have the inner layer. Between the two layers,
Okay.
is the filter.
Okay.
That is the piece of filter.
Mm-hmm.
The one close to your mouth, all right, the inside layer is actually an absorbent layer to absorb the sweat, absorb the liquid. So all the 3 layers, the surgical face masks are basically a high-tech equipment. All the 3 layers function differently. All right, the outer layer, the blue color layer, to resist the water, because you don't want a splash, and then there's the inner layer, the layer between the 2 layers is where the filter is. Then the layer closest to your mouth, the inside layer is basically absorbing liquid so that your sweat can be absorbed into it. All right, so a 3-ply is recommended for a environment where you basically splash is a problem. All right.
Understood, doctor. Thank you.
Okay.
Prof, so that means usually if medical they use the 4-ply, right?
No, 3-ply only, no 4-ply.
No, okay.
No 4-ply, 3-ply only.
3-ply only, okay.
We need to use 3. We need to protect 3 things only. We need to protect against liquid. Then you need a filter, and you need to make sure that in the inside layer, you can absorb your sweat on your voice and your liquid that comes out from when you talk. So when you talk, there is a lot of moisture, correct?
Yes.
So if the inner layer doesn't absorb your moisture, then you basically you go down as liquid into your mouth, till your whole face become very, 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 very wet. All right?
Yes. Understand.
Are you clear?
Yes, Prof. Thank you.
All right, so there's 3 layers inside there. Or you want to see the 3 layers? You know the 3 layers, so just cut your mask and you can see the 3 layers. All right, you can test it basically very simple. Take a drop of liquid, all right, and test it, and see whether the liquid actually flows down or not on the first layer. If the liquid flows down easily, or it forms something like a complete circle or complete sphere, that means the liquid is resistant to water. All right. The inside layer, if you put a drop of water, it should basically the water, the drop should basically spread out more because of the less tension, water tension inside that layer. Okay.
Okay, Prof. Thank you.
Clear,
Prof.
Okay. Anything else? Are you clear about all the protection? Are you clear about the PPE?
Yes, Prof.
Have you have case number 4? Case number 4.
Prof.
Yeah,
Next
almost finishing it.
Next week I'll see you, all right?
Yeah.
All right. Next week we'll see you on case number 4. Thank you very much. Have a nice
Thank you
day.
so much, Doctor.
Thank you.
Bye.
Thank you so much, Prof. Bro, take care.
Thank you, Prof.
Bye.
Have a nice day.
Bye.
Thank you, Doctor. Prof.